Welcome, everyone, to the Temporal 3 podcast. As usual, I am joined by my co host, Mr. Charles Olner. Good morning, Charles.
Good morning.
We're also joined by our senior instructor, Mr. Chris Godwin, fresh back from Atlanta. Chris, welcome.
Good morning.
So, today in the training section, I'd like to talk about an important code in the NICET exam, and that would be NFPA 70. NFPA 70, the National Electrical Code, is allowed in all 4 levels of the NICET fire alarm exam. It's also allowed in some of the other exams like special hazards as well. So it's from a NICET test taking perspective, particularly for a fire alarm perspective, it's a really important code. Chris, how do your students generally feel about NFPA 70?
I have a lot of students that come in as electricians, so they already have a really good background with it, which frustrates me because I don't have as strong a background with it out in the field. The way that I look at it, it's an installer's book, a lot of installation information, but you can take it into your exams. So I've had some students though that struggled a bit with it. It's rough.
Charles, how do you personally feel about NFPA 70? Tell us your deepest personal feelings about this code.
Is that what you want? Well, my first question, Brian, is what addition is allowed into the test?
Excellent question. For fire alarm systems, they are currently testing on 2020. And that's going to raise the antenna of a lot of our students because they'll say, well, wait a minute, isn't the NEC on 2026? And that would be correct. Yes, but does that matter to NICET? Do they care what edition of the code everybody else is using, the rest of the world is using?
No.
Nope. Uh-uh. So
And
2020 is definitely the version you want to have. Now, I like to say with the NEC that the stuff that we're concerned with, mainly the fire alarm stuff there, is pretty static, doesn't change a lot. Obviously, there are minor changes and stuff, and in the rest of the code, I'm sure there's pretty significant changes from the electrical perspective. But from the fire alarm perspective, the parts that we work with are fairly static, but it's always still the best practice if you're going to invest the time and money in the NICET exam to invest the money in having the correct codes for the exam. Would you guys agree with that?
yeah. And Brian, I have two things with the National Electrical Code that I find are important. One is table of contents.
Yes.
Normally, we like to use the index to look up information. In the NEC, the table of contents is so much easier to use.
Absolutely.
The second thing with the National Electrical Code that I think is important is conductor properties table. Chris, have you found that to be important?
Found that's probably if we're looking at it purely from a NICET's perspective, that's probably outside of 760, the biggest thing that gets used in a lot of the exams is the conductor properties table, whether it's what's the resistance of this or you're doing voltage drop. I found that Chapter 9, Table 8, conductor properties table is something that across the board gets thrown at people in the exam.
And what's
Yeah.
frustrating to me is we call it resistance. The National Electrical Code calls it conductor properties. If you don't know that, you don't link the two together.
Yeah. Trying to look up resistance when that's not what it's called. It's not what it's called in the book.
Yep. Yep. Well, you got to remember again, guys, this is a code not written for us, us low voltage guys. It's written for the electrical contractors, what we call in security and fire, the high voltage guys. And the terminology is definitely a bit different. But does that matter to NICET? Do we still have to become familiar with it?
Yes.
Yep, absolutely. So, Charles, you mentioned, and Chris, you mentioned 760, and that is the crux of it, so to speak. That is our article. There is an entire article or chapter in the NEC dedicated to our industry, to fire alarm. And that is probably, as Chris said, probably the most important article in the code. And the neat thing about 760, besides the fact it's very short, it's not a lot of pages of information, so we don't have to dig through a lot. Yeah, 10 pages, 8 pages?
8 pages is it's
8
about
pages, yep. Thank you. And not a lot to dig through, but it also refers to some other articles as well. For example, it refers to Article 300 for general wiring and particular articles of particular requirements in 300. Charles, talk to us about Article 300, how important that is.
It's absolutely essential in the National Electrical Code. Uh, For one thing, it has conduit requirements. So if you're looking for conduit requirements, whether it's EMT, rigid, whatever, you'll find that in Article 300. Second thing is it's the wiring article for the National Electrical Code. It really goes into
Yes.
detail about wiring. I think of it as more of a non-power limited article than power limited. That terminology used in the code is important, and you'll see it in 760. Non-power limited caused me a great deal of confusion when I was first taking my NICET exam. Brian?
Absolutely. That terminology, the NEC, because you don't see that term power limited or non-power limited in 72, which is the code I think of when I think of fire alarm. Chris, did you have similar anxiety?
Um, I wouldn't say I had similar anxiety from going into it, but before the exam, I did get a very strong like, hey, these are two different things that are going to pop up possibly. So, but trying to wrap my head around non-power limited, power limited took a little bit of time and to just really grasp onto. But after a while, it's like, oh, we're
And Brian,
how the current runs.
I'm going to
Got it.
say this. Chris didn't have that same level of anxiety because I'm the one who taught Chris about power limited and non-power limited. So he got a very clear understanding of that from my excellent instruction.
Yes, absolutely. As long as you didn't use any of your jokes, he was okay. Speaking of Article 300 or Chapter 3, there's a section in there that always causes interesting comments in our class, and that's 314.16a, box fill. Chris, what's been your field experience with box fill?
Um, from the field to the book, I didn't know that there was a table that told you you're supposed to have this many in the box. I always just thought and was told, can you close the box? Yes. Then you could put more in there. Yes, you could put more in there. No, put a ring on it and you could put more in there. And that was a lot of what and to find out that there's something in the code that says, hey, if you have this size box of this type, here's how many conductors will fit. Now, I will say, from a realistic perspective, the table only accounts for 1 gauge of conductor for that versus reality, you're not doing just 1 gauge in there. So it gets a little bit gray area with it. But yeah, from field to code, it's like, oh, there's something we're supposed to be doing. We're supposed to be aware of.
Well, and Chris, I think you bring up a good point there. There's one other aspect of it, and that's code to NICET test. What we do in the field may not line up with that table 314.16a, but on your NICET test, that's where the questions about box fill will come from. Brian, would you
Yeah,
agree?
absolutely. You're not going to see a question in a NICET exam about how many extension rings you can put on or how much you can warp the cover before the AHJ calls BS on it. And again, a lot of things in a NICET exam, it's all code, it's all black and white. It's not what we do in the field. You got to be very, very careful about that. So related to 314.16a is Annex C, conduit fill. And that's another one that, in the field we know depends on how much wire lube I use and whether or not I can tie the conductors to the back of my truck and pull them through. And the fill rates are usually different. Chris, you're laughing. It sounds like you've got some real world experience with that.
No, I'm just imagining on a job someone actually trying to do that, and I got a few people that in my mind that I'm like, yeah, they'd probably try that. They'd probably try that.
Oh, we know people who do it. Charles and
Yeah.
I do know a guy who did it with fiber optic cable, tied it to the back of his 4x4 and pulled fiber optic through and wonder why he had broken strands
Yeah.
No idea. No clue.
and didn't put any pull boxes either.
No.
Well, Chris, you mentioned Chapter 9, Table 8, and Charles both Chapter 9, Table out and how important that is. And when reading that table, Chris, what do you think is important that students pay attention to?
You got from how to read the table, there's a couple things. You got to know what gauge a conductor, but once you get there, there's two for each. So you got to figure out that, hey, the top gauge or the top number is your solid, your bottom number is going to be your stranded. From there, you're going to go over and take a look at if it's going to be coded versus uncoded. Here's the thing with coated cable, you're not going to see it in a lot of applications because it's usually going to be used in places that have more moisture. It's there to slow down oxidation. And a lot of your, like, doing workout in Vegas, you don't really have to worry about moisture because there isn't any anywhere.
You just have to use high temperature cables, right?
Yeah, high temperature cables. You go anywhere coastal or doing direct burial, you're going to see more coated cable because you got that moisture in the air or in the ground, wherever it's going to be. And so those are some of the things to take into consideration.
What do
I
you
think.
think, Charles?
I think that table is very useful for doing calculations. It's important that you identify stranded versus solid, as Chris said. Another thing, the temperature rating of the cable makes a difference in its resistance factor as well. The table is set at what temperature is that, Brian? I think 165.
167.
Yeah, Fahrenheit.
167.
Yeah, that's an interesting number, but yeah, you're right. The higher the temperature, the higher the resistance, and they've chose 167 based on previous research on different cable properties. And the other thing we need to remember about electricity is when you run it through cable, it heats up the cable, so that's going to increase the resistance. So that's probably a fair number, and better to have a buffer than have a circuit that doesn't work because the resistance is too high. I'll tell you one thing that it gets me about Chapter 9, Table 8 that I think a lot of students neglect to remember, as this is based on circuit length, not on cable length. Because it is, remember, electricians generally work with single conductor cables unless they're using like Romex or something. But THHN, the everything cable is a single conductor cable. We all deal with jacketed multi-conductor. The table's the electrician's table, so it's structured around the way they work. It's individual conductors or circuit length, how far the electricity has to travel, not how long the cable run is. So those values, when they talk about 1,000 feet of 18 gauge, for example, having a resistance of around 8 ohms, they're talking about 500 feet out, 500 feet back, or 500 feet basically of 18.2. And that's something to remember when we work with that table. I think that trips a lot of people up. Next thing I'd like to talk about, Chris's favorite subject. Chris, please don't hang up on us when we talk about this because I know how much you love this, is duct detectors. Watch from Chris go from being very happy to very angry. Chris loves duct detectors, don't you, Chris?
Duct detectors are the worst. They're just they do a great thing. The purpose of having them is very, very good purpose. Their whole thing is to shut off the air handling unit. Okay, now that good part's out of the way, if you've ever had to go do work on duct detectors, you hate them. You can never find them. When you do find them, they're always up really, really high above the ceiling, and getting to them is always hard. And it doesn't matter how big your ladder is, you're not going to fit to get up there anyway. And then it's just we had a set of duct detectors in this area where the cutout for the ceiling was smaller than my shoulder width, so I'm sitting there trying to contort myself, and that's duct detectors. Duct detectors. They're just bad people. They're just bad people. You got to have them sometimes.
Notice I poked that hornet's nest, Charles.
Well, we both know Chris has issues. Duct detectors is one of them for sure.
You can't be in this industry and not have issues, guys. So duct detectors and code, from the code perspective, there are a couple of codes that are involved in duct detectors. 72 only covers installation requirements if they're required. The code and IBC and 101, the other codes we deal with in fire alarm, only require they're connected to the fire alarm, but the actual codes that determine when they're required are mechanical. So we're talking about NFPA 90A, or in most of the country, IMC, International Mechanical Code. And I like to say the duct detectors are the responsibility of the mechanical contractor, and it depends on the scope of work of the project and the relationship with the fire alarm contractor, who puts them in, who supplies them. But basically, it's the mechanical code that drives them being required. Of course, the fire alarm people always end up servicing them because the HVAC people, that's not their thing. And as Chris said, they perform an important function of preventing smoke spread between compartments. I like to talk about, when they're required. And again, as fire alarm people, even as a fire alarm designer, we may not necessarily make the decision as to when they're required. For example, 90A and IMC, the two codes conflict in the requirements. They conflict in location, they conflict in requirements. 90A says where the supply is greater than 2,000. IMC says where the required on the supply when greater than 2,000. IMC says required on the return when greater than 2,000. So what's the difference? Well, it's from the room perspective. Supply means you're supplying air to the room. Return means you're returning air to be conditioned. So it's from the perspective of the room, whether you're supplying the room or returning air from the room, and it's different locations. And it comes down to what code is the AHJ using as to where that duct detector is located to begin with. They both revolve around 2000 CFM, but where do you put it? A lot of times, again, that may be up to the mechanical, maybe put on the fire alarm guy. What has been your experience with that, fellas?
I have a couple of things on duct detectors. One is it always ends up being a mess. Who puts it in? The HVAC guy or the fire alarm technician? So that's always a problem on the job site. The second thing is what kind of signals do they send to the fire alarm panel? Chris?
As far as signaling goes, depends if it's monitored or not.
They
Alarm
got
versus
two
supervisor.
choices. Brian, what are those choices?
Alarm or supervisory, and it's usually
Yeah.
supervisory. Yeah.
Can a duct detector send a trouble signal when it's
Only-
activated?
When it's activated, no.
No. But so
Yeah.
many times in specifications, it says the duct detector shall be required to send a trouble signal. And that drives me nuts. So
Well, I think
it's supervisory, not trouble.
Yeah, I think we had another sore spot about duct detectors.
Yeah, Brian, why would we want a supervisory instead of alarm?
Because that's an off-normal condition. That's an indication of a system that is supervised by the fire alarm system that needs attention. It's kind of like a sprinkler supervisory when you close a control valve.
But
It's
if the
something that you
smoke
don't
detector
evacuate,
goes off, if a duct detector goes off, shouldn't that be an alarm?
and not the primary purpose, because it's designed to prevent smoke spread. Is there a possibility, and this happens particularly in the fall, the first time you start up the air conditioner in the fall and burn off all the dust off the heating element, you're going to cause it to go into alarm. You're going to trigger it.
I think that's such an important point because firefighters don't want to roll the trucks for a dusty HVAC system.
Yep. Not a good use of resources. I agree.
And do we have other means of detecting a fire? Is the duct detector the only way we can do that?
No.
No.
So,
Absolutely not.
I do want to take a second to point out something that I recently, and I don't know why it took me so long, recently figured out. IBC says they got to be supervisory, but every required system in the IBC has to be monitored. Whereas in 72, it gives you the option of alarm or supervisory. If it's not monitored, it can be an alarm. And so I've always kind of like, why not just do the supervisor? Because IBC says it's always going to be required to be monitored. So there's not the worry of it not being monitored. Whereas 72 is, hey, it's installed. Here you go. But yeah, as far as that, the truck's rolling in Vegas, if the truck's rolling a false alarm, it's a $5,000 fine. So yeah, I'd rather have it be supervisory for that too. Yeah, kicking it on, first heating of fall, you're gonna be burning stuff off. The first time they're kicked on in summer and pushing all that dust through. So yeah.
Absolutely. Well, next topic I'd like to talk about, guys, is a question from the field. We had a question from a student about elevator control. And another one that involves us working with another trade. And we talked, the student and I, we discussed the different applications of detectors for elevator control. That was his particular question. What do the smoke detectors do? What do the heat detectors do? So in general, the smoke detector is a recall device. So smoke detectors are going to perform a recall function. We're going to have them in machine room, the lobby of every floor, and in a sprinklered hoistway or pit. Important to remember that if they're in a hoistway or pit, they have to be listed for use according to 72, because again, is a pit or a hoistway nasty? Yes, absolutely. And in some instances, AHJs will allow heat detectors to be used instead, but that brings up another concern. And the last one, and this is a fairly new addition to the code, which actually makes a lot of sense, is that hoistway detectors have to be accessible from outside the hoistway. Chris, being in the recent on the install side, have you ever worked in a hoistway at the how shall I say, the pleasure of an elevator contractor, hoping he didn't raise the car or lower the car and squish you?
Um, I've only been on the top to go up a few times, but most of the time it was going down into the pit. And you're putting a lot of faith into somebody that a lot of times you just met, and that you're testing it and hoping that they know what they're doing and not accidentally having that drop down and crush you while you're underneath of it. You put a lot of, so to hear that the elevator codes are starting to push for, you got to have it outside or in a way that you can get to it outside. Finally, good job.
Safety issue. It's a place we don't belong.
I kind of feel like they started talking to some of the fire alarm techs and were like, oh, no, that makes more sense now.
Charles, what is your take on this topic?
Well, I agree with what you said about it from a code perspective, Brian. Generally, I personally think a heat detector is better suited for those environments than a smoke.
Absolutely.
If smokes are installed, I certainly wouldn't want them generating an alarm signal. I can say that.
Absolutely. Speaking of heat detectors, heat detectors are generally performing a shutdown function. And that's why I say there is a possible conflict between the two. And heat detectors have different location requirements, machine room and hoistway and pit. So they're not required in the elevator lobbies. And they're generally tripping that shunt trip breaker. But as Charles said, hoistways are generally pretty hostile environments to smoke detectors. So a lot of times we'll want to put in a heat. One solution that I had suggested, but I think it's a great idea, is okay, if we're going to put two heats in, then we put one as a lower temperature heat for recall, one as a higher temperature heat for shutdown. Of course, this requires AHJ approval, but it makes a lot of sense and allows the two functions to be performed because both of them are required by the elevator standard anyway, and allows the fire alarm company to avoid, as Chris said, rolling those trucks. So that from the fire alarm perspective also, because elevator control is a something that's covered in Chapter 21 of NFPA 72, and it talks about the functions that have to be performed. Chris, do fire alarm people control those functions? Do we program the elevator car to go where it's supposed to go?
All the time. I can't tell you how many I've had to do out in the field, get out there and wire it up, pass the relay, go over to the controller that I know everything about and set. No, we don't do any of that. Scope ends at the relay. Scope ends at, hey, how do you want this wired? Put it within 3 feet. Scope ends after that. That's our scope of practice. Our scope also encompasses the devices, but yeah, beyond that, hey, here you go, 3 feet.
Well, and in 2025, it can now be 20 feet if it's in conduit or it's armored. So there you go. You could even be further away. Charles, what has been your experience with that topic?
I agree. I've had nothing contradictory to that at all.
Yeah. And that's the thing. We need to remember as fire alarm people that just like with HVAC, we are generally not qualified to wire the shutdown portion of the air handler. We are not qualified to wire up the elevator equipment. We say to the HVAC people or the elevator people or the other trades we work with, okay, where do you want my relay? I'll put it where you want. It has to be within 3 feet or 20 feet of the circuit or device controlled, and leave it up to them. Just make sure it's electrically compatible. We're not using a low voltage relay to trip a 220 volt circuit. But other than that, yeah, it's really impingent on really on them to do their part right. Of course, when things go wrong, who gets the blame?
Brian.
Brian. No, we're not talking about NTC. We're talking about out in the field.
Hey, I'm talking about anything. If it's a problem, it's Brian's fault.
Well, what are you, my wife? All right, guys. Well, I appreciate the discussion today. Thank you, everyone. Thank you, everyone, to all our listeners, and please join us again for our next session.